Hello. In last video, we discussed how to do paired t-test when two samples are dependent. And we are also seeing how we can do hypothesis testing for the difference between two population mean using t-test and z-test. So far we discussed only two types of test, normal test or normal distribution test, z-test, and t-distribution test or t-test. Okay, so now in this video I am going to introduce you one more test called f-test. Okay, so in the beginning itself, when we discussed about the estimation, we differentiate between population parameter and sample statistic. Okay, so in estimation and hypothesis testing, we are dealing with certain statistic or parameters about mean, then variance, proportions. Population mean, population variance, population proportion. Sample mean, sample variance, and sample proportions. Okay, and sometime we have seen that in order to check whether the population mean is significant or not, okay, we can use z-test or t-test. Okay, and if we wanted to check whether there is a significant difference between two population mean, again we can use z-test or t-test. Okay, so that's all about mean and proportion. But today one more part is left there, that is variance. Okay, so in this video we are going to check how to do hypothesis testing about variance, or how to compare two different population variances. Okay, so f-test, which was developed by Fisher, is mainly used to compare two population variances, not the mean. Okay, to compare two different mean, we are using z-test or t-test depending upon the conditions. Okay, but here we are going to use f-test to compare two different population variances. Okay, so assume that there are two different populations, two different samples that are independent. One is N1 and another one is N2, which are drawn from the same populations. Okay, we are having the same populations. From the same population we have independently drawn two samples, N1 and N2. Okay, so for these samples, what would be our f-test? F is defined as standard deviation of the sample, variance of the samples, this square. Okay, so variance of the sample divided by population variance of the first two samples. Okay, so first sample, first population, what is the variance of the first sample divided by variance of the population, whole divided by variance of the second sample divided by variance of the second populations. Okay, so this statistic follows F distribution with two degrees of freedom for the numerator and degrees of freedom for the denominator. Okay, so there is only one test that is having 2 degrees of freedom, that's called the f-test. F-test is having 2 degrees of freedom. All other tests is having 1 degrees of freedom, but the f-test is having 2 degrees of freedom, one for the numerator and one for the numerator and denominator. Okay, so we already studied how to find out the variances. It is nothing but sigma x minus x bar square divided by n minus 1. Okay, so for the first sample we can check, we can find out sigma x1 minus x bar 1 whole square divided by n1 minus 1. Okay, so when we come to the second sample, 1 will be replaced by 2, all other things will be same. Okay, then if we are collecting, since we are drawing the sample from the same populations, okay, so the population standard deviation will be same. Okay, so what we can do, we can cut the denominator from each part. Okay, so our equation will be f will be equal to s1 square divided by s2 square when s1 is greater than s2. Okay, which has a probability distribution in repeated sampling with degrees of freedom 1 and degrees of freedom 2. Okay, so usually what we do, that larger sample variance is placed as numerator, larger variance group or larger sample variance will be placed as the numerator, so that f will be always positive. Okay, so we are having s1 square and s2 square. Okay, so what will be in the numerator, it will be determined by the sample variance. Which one is the largest sample variance, that should come in numerator. Okay, small variance sample should become as denominator. Clear? Yes. Okay, so this, as I told you, this test was developed by Ronald Fisher, R.A. Fisher. Okay, and this test is also known as variance ratio distributions. Okay, so this test is having a large number of varieties of features, okay, or characteristics. First one, 2 samples should be independent and drawn from the normal distributions or from same populations. Okay, the variability of the measurement in 2 populations should be the same. Variability of measurement in 2 populations should be same. Okay, and f test is not symmetric, and that's why f will never go to negative. So always f distribution is always q to right. Okay, so the shape of the f distribution is depends upon number of degrees of freedoms. Okay, so f test is having 2 degrees of freedom, and these 2 degrees of freedom are the parameters of S distribution. You have to remember that. What is the parameters of the F distribution? Degrees of freedom for the degrees of freedom for the numerator, df1 and df2 are the 2 parameters of the F distributions. Okay, yes. So if you want to know more about these properties, then you can refer some standard textbook. Okay, you can see if all these properties are mathematically explained by S.C. Gupta in his textbook. Okay, so if you want to go for such level, then you can refer that book. Okay, then for what purpose we are using this F test? Okay, so we are having only 3 uses for this F test. The first one, to check whether 2 variants are equal or not. Okay, whether 2 variances in 2 sample variants are sample variance is equal or not. Okay, then second option or second use is to check the equality of several population mean. Okay, so if you are having if you want to compare more than 2 mean, okay, then we have to rely on F test. Okay, so variance and mean both can be computed using F test, but the variance should be more than 2. Sorry, the mean should be not to we have to use F test for comparing more than 2 different mean. Okay, and third one, not to check the significance of the correlation and regression coefficient in multiple correlation test or multiple regression test. Okay, that we will study when we discuss about the econometrics. Clear? Yes. Then let me take an example. Okay, the time taken by workers in performing a job by two methods is given. I am giving you a problem. Okay, so this is a problem associated with the time taken to complete a work, but both are taken in different method. Okay, so we have to check whether the variance of the time distribution is significantly vary or not. Is there is any difference in the time distributions in both method? Is there is a time difference? Okay, so whether we have to check that there is a variances or variations in time in order to do certain work in two different method, that we are going to check. Okay, so we are having data 1 2 3 4 5 6 people are there. 6 people used method 1 and 7 people used, or 7 labor used method 2. Okay, then yes, how we can learn this? The same hypothesis testing procedure we have to adopt here. What is the first step? Specify null and alternative hypothesis. Okay, so what is the null here? Here null is variance don't differ significantly. There is no differences. Okay, here both methods is having no differences in time. Both methods are taking almost same time to the equal time to finish the job. There is no differences. Okay, so the differences is always measured in variance. Okay, so H0 is equal to first sample variance equal to, first population variance is equal to second population variance. We are two sample, in both two samples the variance are, we are two population, in both populations variance are equal. Clear? Yes. Second alternate hypothesis, what will be the alternate hypothesis? Variance differ significantly. Okay, in the slides is different. It is written as variances do not differ, not like that. Variance differ significantly. There is difference. Okay, it may be less than or greater than. It doesn't matter. Okay. Yes. So in this problem, I have computed what is the variances of the first sample and variances of the second sample. Okay, so first sample variance is 16.26 and second sample variance is 22.286. Okay, so as I told you, we have to check which variance is larger or which variance is large. Okay, here we know that S2 is the standard deviation from the second sample is larger than the first sample. Okay, so here in the numerator S2 will appear. Okay, so it will be 22.28 divided by 16.26. It is 1.37. So this is what we call test statistic value of F test, or F value is 1.37. What we do? We go to F table. There is a table called F table, which is developed by R. Fisher itself. Okay, so this test is also based on how many samples you are using and what will be the DF for the numerator and DF for the denominator. Okay, so if you know DF for the numerator and DF for the denominator, we can find out the table F values. Okay, so if you have any books on statistics, you go to the last pages where you can see different table Z, T, then after T you can see F table. Okay, go to that table, you find out the value of table F value. You will find out the critical value for critical F values. Okay, so here our level of significance is 0.05. Okay, it is not 0.25 because this is not a symmetric test. It is always skewed to right. Okay, so there will be only one tail. So f 0.05, for numerator it is, the df is n minus 1, 6. Okay, 7 minus 1, 6, comma, second we are having 6 observation, 6 minus 1, 5. So f value for the level of significance 0.05 for df6 and df5 will be equal to 4.95. So after this, what we do? We have to check, we have to compare these two values, f value and f table values. Okay, so what's the decision? If actual value is less than table value, okay, f is not significant and we are not able to reject the null hypothesis, and hence we have to accept the null. Okay, so if actual value greater than table value, we reject the null hypothesis. But here the actual value is 1.37, table value is higher than the actual value. So we have to, we could not reject, or we do not reject the null hypothesis. We have to accept the null hypothesis. Okay, so what will the hypothesis? Variance do not differ significantly. Okay, so in both methods are one and same. One method is not superior than the other method. Both methods are giving or taking equal time to finish a job. Okay, so I hope that it is clear for you. Okay, so what is the second use? This is the first use, okay, to compare the variances. Then the second use is to compare the mean of several group or several populations, or specifically more than two. If we are having two samples, you can find out the differences, mean differences using z-test and t-test. We discuss it. Okay, mu1 minus mu2. Okay, but here what we are doing, if we are having more than two groups, several groups, and we wanted to find out in all such groups, is there is a differences in the mean value or not, we have to go for ANOVA test. Or we can use f-test, but when we use f-test for such kind of things, it is known as analysis of variance. Okay, so ANOVA test is based on certain assumptions. There are three assumptions. Okay, the first assumption is the population from which the sample is drawn is normally distributed. The population should be normally distributed. Okay, then the second one is the population from which the sample are drawn have the same variance. Variance should be same for all groups. Okay, and the samples drawn from different populations are random and independent. Okay, we have to select the samples randomly, and it should be independent of each samples. Okay, yes. Then if all these assumptions are met, then we can go for ANOVA test. Okay, so before going to ANOVA test, okay, let me tell you certain concept. The first one is variance between samples, variance within the samples. Okay, in this we as you know that there are more than two samples, more than two populations. Okay, so here there will be variance within the samples and between the samples. Okay, so variance between the sample can be measured using MSB, mean square between samples. Okay, and variance within the sample is denoted as MSW, that means mean square within the sample. Okay, so I will tell you how to find out this MSB and MSW. Okay, so MSB means mean square variance between samples, two samples. Okay, MSW means within the samples. Okay, so let me take an example. 5 randomly assigned to 3 groups to experiment with 3 different methods of teaching mathematics. There are 3 different groups. Okay, then all these 3 different groups are given 3 different method of 3 different teaching methods. Okay, or these three groups are taught mathematics in 3 different way. At the end of the semester, a common test was given to all these 5 students. Okay, and we have to find out whether all these groups or all this method is having the same result or not. How we can find out? We can find out using EF test. Okay, yes. So let me tell you one thing. Look at the first method. T1 is the first method, T2 second method, T3 the third method. Okay, so in each method of teaching, 5 students participated. So there are 15 students. Okay, so in the first method, okay, these students got total 324 mark. Okay, in the second method they got 369, and the third group got a total of 385 mark. Okay, and let me give you what is the equation for SSB, SSW and TSS, or what we called SSB plus SSW. Okay, so SSB means what? SSB is equal to T1 square divided by N1. T1 square divided by N1 plus T2 square divided by N2 plus T3 square divided by N3, and if you are having more groups, you can add T4 square divided by N4, like that you can add. Okay, minus sigma x square divided by N. Okay, then what is the SSW then? SSW means sigma x square minus, then the same thing, T1 square plus T2 square plus T3 square divided by N1, N2, N3. Okay, then what is sigma x here? Sigma x is nothing but T1 plus T2 plus T3. Okay, yes. Then how to find out this one? We can find out each one. Okay, then sigma x I told you T1 plus T2 plus T3. So it will be 324 plus 369 plus 338, 1081. What is total N? 15. Okay, then what is sigma x square? 48 square plus 73 square plus 53 square plus up to 67 square. It will be around 8070. So we got sigma x square. What is N? Okay, then what is SSB? T1 square divided by N1. Okay, 324 square divided by 5 plus 369 square divided by 5 plus 388 square divided by 5 minus 1081 square, that is sigma x whole square, 1081 whole square divided by 15. So we get 432.13. This is what SSB. Okay, between variances between the sample. Okay, so what will be the variance within the sample? SSW, sigma x squared. Okay, 8000 something. Okay, 80,000 something. I think it will be 80,000 80,709. Okay, not 8,000, 80,000. Okay, so 80,709 minus the same thing, 324 square divided by 5 plus 369 square divided by 5 plus 388 square divided by 5 is equal to 2372.80. Okay, so what is SST total? What's the total variance? Okay, it would be between the sample variance plus within the sample variance. So it will be 432.13 plus 2372.8. Total is equal to 280.4. Okay, yes. Then coming to what is mean square variance between the sample and mean square within the samples. Okay, now we are going to what is MSB and MSW. Okay, earlier what we have discussed SSB, SSW. Okay, it was between sample sum square, within the sample sum square. Now we are going to what is MSB and MSW. Okay, so MSB is nothing but SSB divided by K minus 1. Okay, so it will be SSB is equal to 432.13 divided by K minus 1. It is equal to 3 minus 1. Okay, so it will be 216.06. Okay, so what is MSW here? SSW divided by N minus K. Okay, so here it will be 2372.80 divided by 15.3. Here N is equal to 15 and K is equal to total number of groups 3. It's equal to 197.73. Okay, so in both case K means what? How many groups are there? Okay, here 1, 2, 3 groups are there. That's why K is equal to 3. So in the MSB, the denominator is K minus 1, 3 minus 1, whereas in MSW denominator is N minus K, 15 minus 3. Okay, so what is F? Now we are going to calculate F. F is equal to MSB divided by MSW. Okay, mean square variation between the sample and mean square variation within the sample. So this will be 216.06 divided by 197.73 is equal to 1.09. So this is the F value. Okay. Now you might have seen ANOVA table. Okay. So what is the ANOVA table? ANOVA table look like this. Okay, so in the first table you can see what is the source of variations. Variance is due to between the sample or within the samples. Okay, so what is the degrees of freedom for between and within? Between for K minus 1, within N minus K. Okay, then what is sum squares? SSB and SSW. Okay, then what is mean square? MSW divided MSW and MSB and MSW. Then what is F? MSB divided by MSW. Okay, so here we can see that in the down column you can see that degrees of freedom for between is 2, within is 12. Okay, sum of square is 432 for between and for within it is 2372 and total is 2804.9. Then what is mean square? 216.06. Okay, then it is 197.73. So what is the value of F? It is 216.06 divided by 197.73. It is equal to 1.09. This is the value of F. Clear? Yes. Now we have to check. we have to do hypothesis testing, okay, whether this is significant or not, whether there is any variations between all these three methods are there or not. For what we can do, the same procedure of hypothesis testing can be applied here. First step, hypothesis testing. How to do that? Whether no variation in the group. What is alternative hypothesis? There is variation. So population 1 square is equal to population small sigma 1 square equal to small sigma 2 square is equal to small sigma 3 square is equal to dot 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 up to the last is equal to 0. There is no variations. That's our null hypothesis. Then not is equal to or greater than or less than or equal to, this will be our null alternative hypothesis. Second one, which distribution we have to use? Now we want to compare three different means. Okay, so for compare three different mean, we need F test. Okay, third one, rejection and acceptance region. How we can find out? First check what kind of confidence level you want. 95%, then 0.5. Okay, 0.05. Then look at what is the numerator and what is the denominator. Degrees of freedom in the numerator and degrees of freedom in the denominator. For numerator it will be n minus k minus 1, and denominator it will be n minus k. Okay, then you find out a proper F value using F tables. Okay, then you find out this value 1.09 using F ANOVA procedure. We have find out it. Okay, then after that what you have to do, you just compare your F value with your table F value. Okay, if actual F value is greater than table value, then we have to reject the hypothesis, or if it is not, then we have to accept the null hypothesis. Clear? So I hope that this sessions we discussed two concepts or two things. What is F test and uses of F test. First one, to compare the variances, two variances, and to compare more than two mean for several means. Okay, so we discussed ANOVA test and usual F test. Okay, so I hope that you understood what is the F test, and who developed, what are the properties or features of this F test. Okay, uses of the F test, then two different uses. Okay, then one more use is there that we will discuss when we discuss the multiple regression methods in econometrics. Okay, so if you have any doubts, you can ask. Okay, and till the next video, thank you. See you, bye.